We are going to discuss about coverage properties. Okay. Assertions are designed to specify expected behavior. Okay. Structural coverage metrics can also be gathered on assert property statements. Structural coverage metrics can also be gathered on assert property statements described in the preceding sections, right? Although knowing which assertions have been exercised is necessary, it is not sufficient for measuring how much DUT has been exercised. Getting this one? So in general, in coverage, we know that two types of coverage: structural coverage and the functional coverage. Okay. So in the assert property, the variables inside that property will automatically will be checked. Okay. So it will give you the structural coverage metrics and all. Okay. Although knowing which assertions have been exercised is necessary, it is not sufficient for measuring how much the DUT has been exercised. The same language used to specify expected behavior can also be used to specify required behavior. So we can use the same assertion coverage to specify expected behavior, to specify required behavior. Okay. So the cover property statement is designed to specify functional coverage points. In system Verilog we have this cover property. Okay. So by using that we can mention our coverage points, coverage metrics. Okay. Functional coverage can be subdivided into two basic classes. What are all those two classes? Data stimulus coverage and protocol coverage. Okay. So the former, the data coverage is concerned with the coverage of computed data and is best measured by using the cover group statement. That cover group is also a keyword. Okay. So by using that cover group we can do this data check and all. The latter is concerned with the coverage of the sequencing or control aspects of DUT. And is best expressed using cover property statements. More details on functional coverage can be found in chapter 6. While we discuss about chapter 6, we're going to see the more on this cover property and cover group and all. Okay. Because of its sequential and physical level nature, protocol coverage is more easily described and gathered by specifying temporal sequences. It's clear, right? Each describes some characteristic protocol element that must be exercised during test. Also, coverage properties can serve as goals for automatic test sequence generation using formal tools. However, there are certain aspects in protocol coverage that there are certain aspects in the protocol coverage that are also best implemented using cover group constructs or a combination of sequence and cover group. Okay. So these are particularly useful when covering the observed latencies between the occurrence